Hello and welcome to another Algebra 1 video tutorial. In Lesson 10.8 we'll be using matrices to solve systems. So our goal will be to solve a 2x2 linear system using matrices. And the big idea would be by finding the inverse of a matrix you can solve systems of linear equations. So in the last section we were able to set up our system, our linear system, into a matrix form, and then this is the section where we'll use an inverse of matrix to solve those systems. Alright, the matrix 1, 0, 0, 1 is called the 2x2 identity matrix, and that's because if you multiply an identity matrix by something like a 2x1 here, you're going to end up with the same thing. So it's kind of like multiplying by 1, because you'd go 1 times h plus 0 times k, that would give you h, and then in the second row here you'd get 0 times h plus 1 times k, which would just give you k. So that's why that is that. Alright, so an inverse is kind of like undoing an operation, and if we were looking at something like 4x equals 12, how do we undo that to get just x equals? Well, we have 4 times x, so the inverse of multiplying x by 4 is dividing by 4 or multiplying by 1/4. So to solve this, we would divide by 4 or multiply by 1/4, and then we get 1x, and 1 is the multiplicative identity, so we end up with x equals 3. Or 1x equals 3, and then we can say that x equals 3 because 1 is the identity. So no different here with a matrix. We're going to get a variable matrix and a constant matrix, or a coefficient matrix times a variable matrix, and we want to get it to be a coefficient matrix of the identity of 1. Okay, and I'll show you what I mean by that in the next set of problems. But the inverse of a 2x2 matrix, we're going to use our calculator, but just to give you an idea of what it would be if you forget your calculator and you have to do this by hand. So if we have matrix A and it's a 2x2, it's A, B, C, D, that's the entries there. The inverse, it looks like it's to the -1 power, but that is the inverse. You would take 1 over A times D minus B times C, and then whatever you get here, you times each value by that. So the A and the D, notice they switch spots. B and C stay in the same spot, but they become their opposites. Okay, so that's kind of confusing. We will end up using a calculator, but I want you to see this by hand as well. All right, and then the last part here, if you take a matrix times its inverse, it's going to equal the identity matrix. No different than if we took 4 times its multiplicative inverse 1/4, we get 1, which is the multiplicative identity. It's kind of the same idea as that. All right, find the inverse of this matrix, a 3, 5, -2, -3 matrix. It's 2x2. Okay, and remember the inverse is going to be 1 over A times D minus BC times that by this 2x2 matrix there. All right, so first we go 1 over A times D, so that would be -9, minus B times C, so 5 times -2, so that would be a -10. Okay, we'll simplify that. Now notice D and A switch spots, so the A becomes the D, D becomes the A, so that's a -3 there and a +3 there. These two B and C stay in the same spots, because remember this was a B, C, D matrix. Okay, B and C stay in the same spots, but they come their opposites, and a +2 like that. Now this would simplify to -9 plus 10, so that's 1 over 1, and if you multiply this matrix by 1, it just stays itself. So the inverse would be -3, -5, 2, 3. Okay, now we're going to show that this matrix is the inverse of the given matrix, and how you would prove that or show that is if you took the matrix times its inverse, it's supposed to be the identity matrix. Okay, so we just have to show that. So we'll take matrix A, which was the 3, 5, -2, -3 matrix, and we're going to multiply it by the -3, -5, 2, 3 matrix. And from last section, to multiply these, it's a 2x2 multiplied by 2x2, so we're going to end up with a 2x2. So these entries, so we'd go 3 times -3, okay, plus 5 times 2, okay, that's the upper left entry, so the upper row with the left column. Now for the upper right, we go the upper row with the right column, so 3 times -5 and 5 times 3. Okay, lower left, lower row with the left column, -2 times -3 and -3 times 2. Okay, lower right would be the lower row with the right column. Negative 2 times negative 5, that would be 10. And negative plus negative 3 times negative 3 times 3 would be negative 9. So that's going to give us 1 there, 0 there, 0 there, and 1 there. And voila, that is the identity matrix on that. Okay, now you won't have to calculate the inverse by hand, but I did want you to see where that came from in case you don't have a calculator that will do matrices. Okay, so drag out your calculator and follow along on how to find the inverse, and we'll multiply these two together to kind of prove that again. So we're going to work this problem again on your calculator. Okay, on your calculator, you see this inverse button, the X inverse button. Okay, see, and right above it is matrix, so you go to second, that button there. And we need to edit a matrix, so you got to go scroll to the right, press enter. And what size of matrix do we have? We have a 2 by 2 matrix. Okay, and then our entries were 3, 5 in the top row, and negative 2, negative 3 in the bottom row. Negative 2, negative 3. Okay, so then you quit out of there, go back to matrix, and on the name select matrix A, and then we want the inverse. So once we have matrix A selected into our home screen, hit the inverse button and press enter, and it'll give us the inverse of the matrix, which is what we calculated by hand, negative 3, negative 5, 2, 3. Now I want to show that if I multiply matrix A by the inverse, it's going to be the identity matrix. Okay, so I go back to matrix, select matrix A, and then times it by, I could do the previous answer, but I'll show you how to grab that again. So go back to matrix, select matrix A again, and but we need the inverse. So we want to take matrix A times its inverse, and it should be the identity matrix, and it is. Okay, so if you have the technology, it speeds up the process by quite a bit. Okay, in the next example, we're going to use matrices to solve the system of linear equations, 3x plus 5y equals negative 23, and negative 2x minus 3y equals 14. So from last section, you need to be able to set up this system with a matrix form. So we need the coefficient matrix, and it's all lined up in the right variables, the right order. So we have a 3, a 5, a negative 2, and a negative 3. Multiplied by the variable matrix xy, because that's the order they came, and equals the constant matrix negative 23, 14. So we're going to call this our matrix A. We're going to call this our variable matrix, and call that our matrix B. So what we want to do is we want to undo this to where it's just xy equals, and in order to get that, we need to take matrix A times its inverse. So we essentially need to multiply both sides by the inverse. What you do to one side, you do to both sides. So what's going to happen here is we're going to basically get the identity matrix. So we're going to get matrix X equals, and our answer will be the inverse matrix of A times B. And then we'll get XY equals some number and some number. And those will be our solutions. X equals this number, Y equals the second number. Let's use our technology of our calculator to do that. So this side we really don't have any work because we know the inverse times this is going to be the identity matrix. So really all we need to get in our calculator is the inverse of A times matrix B, and that is going to be our solution. So let's grab your calculator and do it on there. Okay, now we'll go back into our matrix, and remember what I put in matrix A was the coefficient matrix for this particular problem. We already did the inverse of this. I've already shown you that. So we have this already typed in, 3, 5, negative 2, negative 3. Now we need to go to matrix and enter edit matrix B because we have nothing in there yet. That's going to be our constant matrix, and it is a 2 by 1 matrix. Okay, and in that was negative 23 and 14. Negative 23 in the top, 14 in the bottom row. Okay, so we need to get to a home screen, and we need to take this inverse matrix times matrix B. So we need to select matrix A, and we need the inverse of it, and we're going to times it by matrix B, because we've already proven that it's going to matrix A times its inverse is going to be 1 0 0 1. We've already worked that previously. We just need to get matrix B, option 2, and what this is going to be is our answer. Okay, so really what we have done is the left side is our variables x, y, and then equals. So x equals -1 and y equals -4. That becomes quite simple if you know how to solve these with the matrix, which is what you're learning now. We'll work one more example to see if you got the hang of it. Okay, so this simply says x equals -1, y equals -4, and that is our solution. Okay, before we work another example, the summary of the matrix method. So we always want to set it up as a coefficient matrix A times the variable matrix equals the constant matrix. And we'll call it matrix B. That's just the easiest way to remember this. And they're the first two in your calculator as well, A and B. Okay, so on the left side, we get the inverse times its original matrix, and that becomes the identity matrix. The identity matrix times xy is just going to be xy. So there really isn't any work, but that's the properties and what's really happening on the left side as we solve these. The work becomes, or the solution becomes on the right side, where we take the inverse of A times matrix B, and that is our solution. The matrix where our solutions will be. Now this doesn't always work. The left side will just give the variables. The right side is the solutions, but caution, just as 0 doesn't have a multiplicative inverse, not every 2 by 2 matrix has multiplicative inverse. So if you have a coefficient matrix that doesn't have an inverse, there's not going to be a unique solution. So there's two things that could happen. There could be infinitely many solutions or no solutions. So that's those parallel lines that could be non-intersecting or coincident, where they're the same line. In your calculator, if you go to solve this using inverses, you may get an error message that says singular matrix. That means there's either infinitely many solutions or no solutions, and you have to solve those by hand or graph them and take a look at what the answer would be. Okay, we'll try one more here. Solve the system using matrices. So we need to get it in matrix form first before we tie into this. So we would have our coefficient matrix, which would be 2.3 and 1y. And the bottom row, so they're all lined up, ready to go. So sometimes you'll have to rearrange these to get it in matrix form. But 3.1 and 2.4. And then our variable matrix is xy. And equals -5.5, -1.1. So we'll call this matrix A, we'll call this matrix X, which we don't end up typing that in the calculator, and this is matrix B. So we need to end up getting X equals the inverse of A times B. So in our calculator, let's get matrix A entered in, matrix B entered in, and multiply the two, and that should be our solutions to get that. So we'll get an XY matrix that we don't actually see, equals some number and some number for our solutions. Okay, so let's try it on your calculator, or if you want to try it, pause the video and try it first by yourself. That might be a good idea to do. See if you got the hang of this with the matrix method. Okay, so we'll go back to matrix, and we need to edit matrix A. It's the 2 by 2, and the top row was 2.3 and 1. The bottom row was 3.1 and 2.4. Okay, we need to enter in matrix B, or edit matrix B, I should say. Okay, and our constant matrix was -5.5 and -1.1. Okay, now the last thing I have done is matrix A inverse times B. You saw how to get that, but if that's the last thing I've done, I can just press enter again and it'll repeat that operation, and I get, so what I really will see, well, I don't see, but what that means is my variables were x, y, so x equals -5 and y equals 6. So you don't have to go through all those menus and select those if the last thing operation you've done is the inverse of A times B, which is what you'll do in the homework. So you should be able to speed up the process by only going into the edit menu and changing what matrix A and B are, and then you can use that to help solve it for you. Alright, pretty easy once you get the hang of this. Alright, that wraps this up. Your assignment will be 10-8, page 632, number 2 through 24 evens. Don't be afraid to watch this video, a few parts, over and over until you get the hang of it, because once you get the hang of it, solving linear systems with 2 or more variables becomes quite simple. There's also a couple more there's one more method to solve these in a later course. Alright, thanks for watching, and we'll see you next time.